Hello! Here's a question. Do you know who this guy is? Elon Musk. He's this quirky, crazy personality who's known for having created some pretty amazing things. He's the person behind Tesla, the company that produces electric, battery-powered cars. His earlier claim to fame was creating PayPal, a very popular website for online money transfers. And now he's behind SpaceX, a space flight company with the ultimate goal of creating a settlement on Mars with people. Okay, so what's this got to do with Deno? Well, there's this really well-made unofficial API for data on SpaceX rockets, launches, and all kinds of other data. We're going to create a Deno program which queries this API to find out some interesting things on SpaceX. And we can later start tracking this information, for example, in an API. All right, but how are we going to do this? We're going to import some other Deno library to do API requests, right? Well, not really. We're going to use the standard JavaScript fetch function. So if we go to the Deno runtime docs and go down to the fetch function, we can see it's the same function that we already know from browsers. These are the exact same interfaces that we see in the official documentation. Down here. In Deno, there's no need for any external libraries or so-called polyfills. Let's dive in the next video. Let's get coding and let's make some API requests to our API from Deno. So we're going to start by making a function to download launch data. And inside of this function, we're going to make a request using the fetch API to our SpaceX API, which is at https api.spacexdata.com. And this is a versioned API, so it's at version 3 as of the recording of this video. And we're querying the launches collection. So this defaults to a HTTP GET request. But if we wanted to, we could also do a POST request by passing in this options object. So we can pass in parameters like the method and say that's a POST. And we can also pass in the body and pass in a stringified object. So that could be any object. But in our case, we're getting the data, so we'll change the method back to a get, and we'll assign this to a variable. So we'll call it response. And I'll fix this. And this response object here is actually going to include not just the body, which is unparsed, but also a lot of metadata about the response. So we can use this response.json function that's part of this object to return the parsed JSON body. And we're going to call this the launch data. And of course, because we're making an await to an asynchronous function, we need to make our function async. And when we call it, we're going to use the await statement. All right, and let's just do a console.log of our launch data. And try to run our program. So we'll need the allow net permission. So we'll do Deno run. But this time we're going to be extra specific about which URLs we're allowing requests to. So instead of allowing our API to make requests to any site on the internet, we're going to say only to api.spacexdata.com. Okay. Oops, and we're getting the promise here. What I forgot to do is await this promise that's being returned from this response.json asynchronous method. Let's run it again. And we're getting our data back from the SpaceX API. There we have it. Remember how we could use the built-in fetch function from the browser instead of importing something new? This will be a huge relief if you're a full-stack developer and you tend to move back and forth between front-end and back-end code. I've been in countless situations like this, and trust me, not having to worry about two different APIs and two different sets of error handling and overall behavior will be a big relief. Usually these external libraries, or so-called polyfills in runtimes like Node, don't actually provide the exact same interface or API that browsers do. So we now have this mental overhead where each time we switch back and forth, we have to remember which API we're working with. And this confusion takes our focus away from the problems that we actually want to solve. So Deno's philosophy of staying true to the browser APIs is greatly appreciated. Thanks, Deno. We've already used console.log many times to print things to the console. But usually for larger projects, we'll need more advanced functionality to differentiate between debug logs and error logs, for example. In Deno, you can do this using the standard logging library. We can import this library by doing import *as log from deno.land/std/log mod.ts. And we can use a function like log.info. So for example, if we wanted to say downloading launch data prior to making this fetch request here, we could do log.info instead of console.log and pass in our string. So downloading launch data. Now we know that a request is about to be made to download the list of all SpaceX launches. And how do we know if our HTTP request succeeded? We can check this response.ok property on the response object. So we can do if response.ok. And if this is true, that means that the HTTP code returned from the request is in the 200 range. So you can see here on the Mozilla developer documentation that this represents success codes. So what happens if the response failed? So this is false. Well, we can throw a new error. So say new error, launch, data, download, failed. But we can also log that error. And we don't necessarily want this to look the same as an informational message. So the Deno logger provides log.warning to warn us of an issue in the code. So we can say problem downloading launch data. In Node.js, we'd have large packages like Winston to help us with logging tasks like this. This would, for example, log our errors not just to the terminal, but also to a log file, or even to some external service, like a log aggregation service. Well, the great news is that Deno comes with all of this functionality in the log module. So if we go to the standard library and the log module, we can see here in the documentation that it has 5 different log levels that it provides. So from the lowest priority, we have debug, to the highest priority, we have critical. And we can use this log.setup function here to configure our logger. So we can specify a console logger and the minimum log level to show in that log. Or we can specify a file handler where anything below a warning will not be shown, and it's going to be output to log.txt with this text format. We can use this to color code our input by what type it is. Or we can use even more advanced functionality like log rotation. So once a log grows past a certain size, you can archive and compress it and move new logs to a new file. So this is very handy when you're working on production systems, which can generate gigabytes of logs over time and eventually fill up your disk space. Okay, so how does this look when we run it? Well, let me comment out this launch data. And then when we run it, we can see this info statement in blue here, preceded by the log level. And we didn't see this warning because our fetch request succeeded. But we could also, for example, go back and configure our logger using the example here. So call this log.setup function ahead of any of our statements. And we'll say that we only have a default logger here. That only outputs to the console. So if we do this, we should see the exact same behavior that we saw previously. So if I rerun the program, all right. But now if I change either of these minimum log levels to something higher than info, it will no longer print our informational message. Set this to warning. Look at that. It no longer prints. And the same holds true for this console handler here. But if I now output a warning below this, that will now show. And you see it's color-coded. This is pretty cool. This is not something that Node.js came out of the box with. And Deno is making our life pretty nice by making this a standard feature. Remember how Deno caches our imports? So if I hover over this URL, you can see that it's actually being loaded from my local machine. The first time I ran this program, Deno saved that file for me locally so that I don't need to be connected to the internet to run the code. Well, you might run into a situation where you have to do Deno run -- reload to get the behavior you expect. As you can see, this is re-downloading the modules in our cache and recompiling them. This can be useful if, for example, the version of the module that was in our Deno cache became out of date with the version of Deno that we're running. Or if one of the modules in our cache needs to be upgraded to a newer version of that module. So remember, the -- reload flag is worth a try if you're running into issues. Just a little tip for when you're struggling with some unexpected behavior. All right, see you in the next one. Welcome back. Let's see what data we got back from the SpaceX API and explore it a little bit further. We're going to start by flexing that TypeScript muscle again. So let's define a map, and we're going to call it launches. A map is a JavaScript built-in that holds key value pairs, just like a normal JavaScript object. So name Elon. But among other differences, an object must have keys that are strings or symbols, whereas keys in maps can be anything, even JavaScript functions. And maps are also ordered collections, whereas objects make no guarantees about preserving the order of their properties. Our map will have keys that are numbers mapping to launches. So we can do this in TypeScript by passing in the number and mapping it to a launch, where a launch will be an interface that we define with the data that we want to fetch from the API. So in our case, let's start with flight number, and that's going to be a number. And we'll also have the mission, so that can be a string. Next, we'll go over the launch data that we have here, and using a for of statement. So we'll do const launch of launch data. And we'll create an object, flight data, with just the most important data that we're interested in. So flight number, which maps to this property from our response, which is going to be flight number, and the mission, which corresponds to this mission name. And finally, we'll add our flight data to our map. So we can use this launches collection, or this launches map, and use the set method, passing in our flight data dot flight number as the key. The value is going to be all of the flight data. Okay, so that was a lot of typing. Let's see what we've fetched from the API. We're going to use this log.info and pass in the flight data. Because this is an object, we're going to use JSON.stringify to turn it into a string. Let's see what launches are coming up. So we're going to run our program. Okay, and we can see that we've gotten back 108 different missions. And among other things, we can see that there's this crewed flight here. After years of cargo-only flights, NASA is finally sending people back into space from the United States. I'll see you in the next one. Welcome back. Let's use Postman to inspect the SpaceX API response and look for a few more pieces of data that we can then explore. Postman is a collaborative API testing tool. What does that mean? Well, Postman allows you to create HTTP requests, organize them into collections, and share them with your teammates. It provides some useful features, like integration with REST and SOAP and GraphQL. These are all different ways of making requests against a backend. It also provides automated testing, so you can run your API requests against your server to check that you haven't broken anything in production. There's this design and mock functionality, which allows you to develop your front end against a backend that hasn't been built yet. So your Postman is sending back requests as if it were the actual backend. This is really cool. It also has documentation. Postman will document your API based on the requests and responses you've made. And it'll also monitor your API by checking this health status and letting you know if, for example, your API is taking a break and it's gone down. And there's also workspaces, so you can share the requests that you've made with your team to make sure that you're all on the same page around how requests and responses look. It's a great collaboration tool. Okay, so these are all great, but how do we use it? First, I wanted to mention Insomnia. Insomnia is another great tool to help design and debug APIs. It's a competitor to Postman with similar features, but I personally find Postman a little bit more fully featured, while Insomnia is known for its simple and easy-to-use user interface. Whichever you choose, they're both excellent tools which will get the job done. Okay, let's check out Postman. We'll start by creating a collection, and we'll call it SpaceX API. We'll create that collection, and inside of it, we'll add a request, which we'll call get launches. We'll save that, and then we'll pass in the URL to our SpaceX API launches collection right here, and click send. So now Postman is making that request to our API and passing back the response. Whether it's JSON or XML, HTML, or text, it will parse that response. And if we were making a post request, we could set up the body here. And we can also set the headers in our request, or even inspect the headers from the response from the backend that we just made. So we'll explore all of this more later on in the course. But for now, let's take a look at our body. We can see that we got a 200 response, and the request took 224 milliseconds. And we've gotten some standard information. So we have our flight number and we have our mission name. But let's see, we also have some information around the rocket that's being used for this launch. So we can see this one is a Falcon 1, the first SpaceX rocket. We now have the Falcon 9 and the Falcon Heavy, and soon to be the Spaceship, which is SpaceX's interplanetary rocket. And each rocket has different stages, and we can see that part of this second stage is a series of payloads. Now, these payloads are the objects that the rocket is carrying, and these payloads can come from different customers. You see, SpaceX is a commercial company after all. They're not a government or an organization like NASA is. So we can see here that DARPA, which is a military organization in the United States, was the first customer for SpaceX. And if we scroll down, we can see the same data for subsequent flights. So we have another Falcon 1 rocket. And we can see that it was launched from this island here that I've personally never heard of. So we've found some interesting data to explore programmatically. Before we do that, let's see how this would look in Insomnia. So you can see the UI isn't too different, but we'll start by making a new request, which we'll call SpaceX Launches, and then we'll create it. And up here, we'll pass in the URL to our launches collection. And when we send it, you can see we get very same response. And we can also explore the header like we did before. Two really great tools. All right, I'll see you on the next one. Welcome back. We've found some data about the rockets used in SpaceX launches. Let's integrate this into our Deno application. So we have a rocket name, which we can add to our interface. And that's a string. And we'll also add the customers. So that's going to be an array of strings. Two pieces of information that are going to be interesting to find out about each of these launches. So we're going to add our rocket here. And remember that it was under this rocket property, but it was actually nested. So if we go back to Postman, we can see that the rocket name is nested under the rocket. So we're going to call rocket_name. And then for the customer data, remember how it was under the second stage of the rocket, under this customers array? So we're going to have to parse this response to gather this data. And remember, there's potentially multiple payloads here. So this actually won't be that hard to parse. What we're going to do is we're going to create a new variable here for the customers. And remember how we used Lodash in our File IO example? We're going to do the same thing here. So import star as underscore from Lodash. We're going to use another function from Lodash this time that you might have heard of if you're really into functional programming. And that function is called flatmap. So let's find that in the documentation. And we can see here that essentially what this does is it flattens the input list into the output list by running this function on every item in the input. So we're going to call underscore dot flatmap to create our customers array. And we're going to fetch this payloads array first. And this payload was at launch, rocket, and then the second stage, remember, at the payloads property. So now that we've selected our payloads, which we can see here, each payload can have a customers property with more than one customers. So we want to turn all of these lists into a single list for the rocket. So our flatmap function here is going to take a payload and it's just going to return the payload's customers. That's it. Now, those nested customers are going to be turned into a single list for this entire launch. Flatmap is an extremely useful example of functional programming. All right, so now that we have our customers, we can add it to our flight data. So let's see who's been flying on our SpaceX rockets. Let's run our program. And looks like TypeScript's complaining that payload implicitly has an any type. All right, so a quick way we can fix this, because we know that we're just getting the customers array, we can say that we can make this explicit by giving payload the any type. Just a little shortcut. Normally we could define the entire type for this entire response and say that payload is a list with certain properties. But this is just a small piece of code, so we're not going to spend the time to do that. TypeScript allows us to pick and choose which level of safety we need depending on how often a piece of code is going to be used and reused. All right, let's give this another try. Okay, I typed out strings instead of string. It happens. Third try's the charm, right? Beautiful. So now we can see that SpaceX is flying with these Falcon 9 rockets recently. They haven't launched their spaceship rocket yet. And we can see that there's an interesting mix of customers here. We have the United States Air Force. We have NASA, of course. We have the country of South Korea. And then we have some rockets with many different customers. So if we scroll up, we can see, for example, that this rocket had 2 customers. And this one here had many. University of Texas and the US Naval Academy, the Planetary Society. Looks like SpaceX is doing pretty well. Very, very cool stuff. I'll see you in the next one. Say I wanted to show a message that shows us the amount of launches that we fetched from the SpaceX API. What we could do is add a log.info statement right after we download our data that says downloaded data for, and then use this launches.size property that our map exposes to say that's the amount of SpaceX launches that we fetched. But say I wanted to export this function, and I added export ahead of this async function declaration. And maybe the module that's importing this doesn't want to show this log when it's using our function. Maybe it's using a different logging format. So we can add a condition here that says if import.meta.main, we execute this code. Now, if we log.info our stringified import.meta and execute this program, we can see that not only is our condition true, because we just showed that we downloaded 107 SpaceX launches, but we also get this import.meta object that contains URL and main properties. Import.meta is an object defined in modules that provides metadata, so data about the data, or more specifically, context on how the module is being executed. So we have main, which tells us whether the module is being run as a standalone program, and it's false when the module is being imported inside of another module. And we have URL, which contains the full, absolute path to the current file, which means we can detect which folder our module is currently executing from. This meta object is available when run by Deno or imported by another module. But when I run the Deno REPL and say I do import.meta, Deno tells me that import.meta is only available inside of modules. This same object is available for JavaScript scripts that are run inside the browser in the script tag. It's part of the HTML specification, and it can be extended depending on the implementation. So inside of the browser, you generally have just the URL, whereas Deno adds this meta.main property that we see here. Now we know how to set the behavior of our Deno modules depending on whether they're imported or run as a standalone program. It's best practice in Deno to include this if you think your module will be run as a standalone program, and you also want to allow others to use it as a module. Allowing others to build on what you've created is a core part of the open source philosophy that Deno follows.